Hey, welcome back. Good to see you again. Hope you're all well. Thanks for joining the channel. Today on the bench I have this sad looking Harman Kardon hk870 power amplifier. This is a eBay purchase, and I purchased it with funds from the channel. So this is from you guys donating money to me and the money I make on ad revenue. Purchase this one. I'm going to do a full restore on it and probably offer it for sale at the end when I'm done. See how this goes. I don't know. This one came in kind of rough shape. It's got some scratches. Looks like scratches, but they might actually clean up. It looks like a scuff of some kind across the aluminum front, and this is all aluminum. Very sparse looking machine. It's only have a power button and two lights. One that says wait, and the other one says on, and then it says stereo power amplifier in the bottom here. I think these are 100 watts a channel. I'm not sure. Got some stains on the top. Looks like dust, paint, maybe paint overspray. See if that cleans up. The back has really nothing on it. Has input for 2 channels, a ground screw, and an output for 2 sets of speakers. That's it. A power cord, and that's all there is to this. But it is quite heavy. It's got some stuff going on inside. So let's pull the cover off and have a look inside. See what it is. Alright, let's pull the lid off. The lid looks nice and clean on the inside, which is a good sign. Hasn't been baked for thousands of hours. That's a good thing. And then when we look inside, we see we got some stuff happening. Yes, we have a big toroidal transformer, heat sinks, one for each channel, looks like. Nice beefy power supply across the back with 4 filter caps, bridge rectifier. And then all down here is our, looks like driver board with all of our driver semiconductors. And we have more power supply here. I don't know why we have separate power supplies. That's interesting. This is the way it came to me. It came to me with no fuse. And that's a 5 amp 125 volts. Okay, so I think what they're doing here is they're fusing the B plus for each channel, plus and minus, plus and minus. And I think that's this fuse here would be the main power fuse. I don't know if I had this off. Somebody's had it. I don't know if I can get it off. It's stuck on there pretty good. It's glued or something. Yeah, I'll have to pry that off. It's got that conductive glue on it holding it down. I don't think anybody's been in here, but if I peel it up and look underneath, it's intact. So looks like we might have a dead channel here if we have a blown fuse. This one's intact though. I don't know what that means. It means we could have a shorted semiconductor on the outputs. But anyways, not much to it. It's pretty much one big board from front to back that's got cutouts and punched for air ventilation. Quite a bit of the board is punched out here. And it looks like it's all one board from front to back. That cap feels loose. Everybody says, oh, the capacitors are domed on top there, they have to go. No, that's just a plastic piece of disc they put there, and it naturally bows up for some reason. Okay, let me get the bottom off. Okay, the screws are out. Yeah, that's a fair amount of dust. And we don't see much going on under here. Actually, it's not 2 boards, it's actually not one board, it's 2 boards. We have our power supply. I think this is power supply back here, and then a separate board for the main. Not much happening on this side, just a power transformer and empty space. And our power switch. Very Looks like it's very well built together, put together. It has some aluminum covers for the output devices. I don't know why they did that. Now this, I don't think this amplifier is you can put in bridge mode either. So there's our devices here. 2SB755, 2SD845. And these look like they are well cooked. Things have gotten hot here. The glue they used is turned black and just turned to crust. Okay, I'm going to get these covers off and then we'll check all these devices, make sure that they're intact. Okay, I'm already spotting problems. Now I took those 4 aluminum covers off. They had a little bit of paste on here. It's all dried up, completely crusted. I don't know what they're trying to do with those covers. Just protect the diode or the transistors from maybe stray noise, but I don't know why they would want to do that. But there is a problem here. Well, actually, first there's 2 temperature sensing stabilizers here that you got to be careful of. They were screwed down with the cover plate, so you got to remember that. But over here, have a look at this right here. I'm going to zoom in. It looks like things got hot here. Now this pin here, I can move it. I don't know if you can see it moving. That's completely cracked free of the board. And the center conductor is the collector. That one's completely crack free of the board as well. So we got 2 cracked solders, which would be enough to take out this channel, I think. I don't know. Some of these other ones don't look great either. That one's loose. Look at that. Oh, you can't see it. This one here. That one's broken free. That one's broken free. That one's broken free. So all 3 of these pins have broken free on this transistor from the solder. I don't see anything on this one. Let's look at some of these other ones here. So yeah, this thing has been... I can't really see. That one looks like it's broken free too, but it's not moving. It's just cracked. That one's good. Just giving them a little tug, see if they move. That one might be cracked. These 2. Yeah, so we got problems here. These joints on these transistors are broken free. Now I wonder what that did to the amplifier itself. I hope we didn't blow up any devices. Let's test them now and see how good they are. Alright, so which is the base on these? I think this one here is the base. Yeah. Looks like we got a short. A short circuit. Okay. That one's done. See, I don't even need to unsolder it. It just comes out on its own free will. Look at that. Look at this. They smeared paste on, but it never even made contact except for a little bit in the center here. You can still see the brush marks. So what's preventing this from making contact? They didn't screw it down enough, or what the story is. But that never did make thermal contact. That's probably the reason why these things self-destructed. And it's all completely hardened, dried. It's like paint. It's not grease anymore, that's for sure. Yeah. Okay, one dead transistor. Let's see what else we can find here. That one looks okay. Charging up as a cap. Is that a short? Can't seem to get a connection here. Open this way. This way says, okay, that's good. That one's okay, seems. Shorted, shorted, shorted. Looks like we're going to be replacing transistors here. Okay, this one here. This one's secured. I'm going to desolder that one. Shorted, shorted, shorted. Okay, I think this is the side with all the carnage. Hopefully this side's okay. I think we had a couple problems here. I think we had excessive bias and poor heat sinking led to transistors just failing. This one here still attached. Okay, let's pull this one out. Don't have enough heat. There we go. This one sort of made contact, but the paste is completely dried out. That one's not bad either. Alright, let's go to the other channel. Where are we here? It's good. Good. It's good. 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 Good, good, good. Good, good, good. Okay, so we had one dead channel, two dead transistors in one channel. It's interesting. Failure of this. This is interesting too. So I'm going to remove all these because obviously this is a problem here. And we're going to address that too. I'm going to see what we can find for replacements. This is not going to be easy. I do have some transistors we can sub in there. They'll probably be bigger. Let me try one. These bad boys here will probably work. The holes line up. Yeah, that'll work. We'll use those transistors. Okay, so I'll remove the rest of these, and then I'll start cleaning up the surfaces and get it all prepped for new transistors. Another update here. I got the transistors removed and it shows a bigger picture. So if you have one of these amps, I suggest you do this today. Unplug it and stop using it, because about half of the connections to these transistors were cracked and broken. The other half held up okay. All these transistors here, this one here, this one, this one, this one, this one, this one, they have very little compound in the center. This one didn't even make contact. You can see where the contact was made. When they screwed the transistor down, this area here is where it all contacted. In this area here, that's where all the thermal heat was going through these two patches, and all of this here was up in the air and insulated from the heatsink. That's a huge problem on all these transistors except for maybe this one, and this one's half kind of, but you can still see the paint marks here, the brush marks from the factory where they put the putty on, or the compound. They didn't use enough, and yeah, I don't know, maybe these didn't come flat from the factory. Maybe they have a slight dish to them, I don't know. But you can see on this one, there's in the center, there's no contact, and then all the contact was made on the two outside screw holes. But that's where the heat's generated, right in the center where the die is, and that's why these cook so bad, because the thermal resistance. Now I had another problem here. All these filter capacitor joints I got broken solder joints on these too. That's a big thing too, because all these, this one's cracked, this one's cracked, this one's cracked, this one's cracked. All four of these capacitors either were or weren't in the circuit. So he was probably getting lots of snap, crackle, pop, hum when you're using this amplifier just from these joints alone. That's a bad thing. I'm looking up here, the joints for the daughter board, they look okay. But yeah, all these cracks was huge. So if you do have one of these, I suggest you go and visually inspect it, resolder it, and repaste all 8 transistors. Get them so they're cooling properly. Alright, now what are we going to do with this thing? Well, I think I got 3 dead transistors out of the 8. I think I'm going to go through and test all these. I don't know if they're going to go back in. I think I might. They look pretty tired. You can see how they're discolored from heat. The green ones aren't green anymore, they're more of a dark. That's the most green one, and look at this one. This one's cooked. So they've seen a lot of heat. I think I might just retire all these and put all brand new, and that way we know it's going to be good. I've got this board here, and there is some cracks on these capacitors as well. Looks like there's a regulator or a transistor here. That's all cracked joints. So this thing probably had a really hard life. It was used right up into the end, and then it couldn't hang on any longer and gave up. Okay, I just started tearing things apart and getting ready. Now these caps are the filter caps for the power amplifier. These are 10,000 microfarad, 63 volts, and they measure probably, I think the worst one measures 9100. The other, there's 2 that measure very close to 10,000, and then there's one at 9500. So these are all fine. These are Elnas. You can see this Elna for audio with gold lettering. They just need to be cleaned up and put back in. It's too bad they couldn't have soldered them to the board, because all 4 of them, the negative post was cracked and disconnected from the circuit. So yeah, that's a big problem. So I'm going to go in here. I have to remove this shield or strut or cover, whatever you want to call it, because there is a cap underneath there that I can't access. Well, I can access it now, but I didn't even know it existed before. But I also want to get in here and clean up all this old glue. There's a resistor here with some green fuzzy legs because it's corroding from the glue. And I want to get this cover off so I can clean all that out, which means I need to remove these bridge rectifiers. Okay, I have to remove those, and then this cover will come free. So I'll do that. I also have the driver board and the driver power supply removed, and I have that here. Here's the driver power supply. They have a separate power supply for the driver stage, and if you can see that right on top, power supply for driver stage. And it has 4 capacitors, 2 for each channel, has fusible resistors, and that's pretty much it. It's just a basic. I think this might be a regulated supply here, because it has a Zener diode next to it, and that is a 2SB649 transistor, little couple caps. So that might be just for the pilot lamps or something like that. Who knows? Seems like it's dissipating a fair amount of heat though. So I might want to put a little heat sink on there. I'm going to clean this up I haven't checked these caps yet, but I think they're fine. Okay, and then onto the driver board itself. Very few caps on this thing. There's 4 here in the middle, 2, and I think that's it for this board. There's 2 caps back here, 1 cap here, and these 4 caps. These are Elna. I'll show you. Elna for audio. They are 220 microfarad, and they are wired back to back. You can see the polarity is opposite each other, and all they do is they provide input isolation, DC isolation for the input. So I'm going to remove all these ugly things and put probably 2 100 microfarad cap, a bipolar cap in to replace these 4, and I should clean that up a bit. And I desoldered the sockets before I realized they were sockets, so whatever, I'll put those back in. I don't really like sockets in these positions because these contacts can go dirty and cause intermittence, and then all hell breaks loose. So I'll put these back on the board and get these few caps changed. There's not very many caps, like I said, just a handful. And then I'll go through and check semiconductors on this, because we might have some blown semiconductors on this if we had bad outputs. Okay, update time. So I went through and checked all these resistors. They're all fine. All these, I replaced these 2 caps, and I put a little heatsink on this transistor just to give it a little fighting chance. I tested it, it's fine. It's doing okay, but I just put the heatsink on there just to keep it cool. I'm going to put these caps back in. These are 4700. They measured around 44, 4500. Alright, so they're all okay. They're fine. No need to replace these. These are the caps that supply very little current to the front stages of the amplifier. I don't know why they had such a ridiculously large amount of capacitance, but whatever. In their wisdom, they did it. So I'm going to put these back on the board. Get the board cleaned from all the old glue. I'm going to put this back on the board, and then I'm going to add filter caps or bypass caps to each of these electrolytics. I'm just going to add a 1 microfarad film cap in this position right here, just on each one, just to help keep noise down. And then I think this one's done. Yeah, this bracket here, I think I'm gonna take it. Look at the corrosion on the inside. I think I'm gonna give it a light sanding and just paint it with some flat black, just to clean that up. The glue is actually eating away at the inside here. You can see it. It gives off corrosive gases. So here's yeah, so I'm just going to paint this up just to stop that corrosion. And then we'll work on this thing, this mess. Hopefully we don't find too much wrong with this. I don't see any damage to this board, but that doesn't mean we won't have a bad transistor or open resistor somewhere. I don't see anything wrong here. It all looks really good. Alright, so I'm just working my way through this board. Not much to do really on these Harman Kardons. I replaced these 4 caps and I replaced these 4 caps. These are all bypass capacitors on the power supplies. So yeah, there's no electrolytics in the audio path whatsoever. And then I added MLCCs to each one just to help with the bypassing. Now I'm just checking transistors, and I haven't found any dead ones or bad ones. They're all good. They're all testing fine. I checked all the resistors. They're all fine. So really nothing happened to this board. That's surprising. Now I took off the heatsink, and I'm going to re-grease all the transistors and put it back together. After that's done, I think I can start assembly. I finished this power supply board. It's all back together. We've got those caps in place, and this one's ready to go. Yeah, I'm pretty much, this is a one-day job for me. This is like nothing. Just wanted to mention these joints here on these connectors, they are pretty much mostly all of them are cracked. On this one, about half of them on this one. So the cracks aren't on the main board, the cracks are on the riser card. Going through cleaning this up, and it's just a chore. Like, I've been working on this for about an hour now, cleaning the board, all the flux, the old caked on, baked on flux, and this this old heat sink compound does not want to move. I tried alcohol, I tried this stuff. Usually this stuff works. It kind of breaks down the oils and sets it free, but it can't fight my brass brush, and that's the one thing I'm using today, and it seems to be the only thing effective against this dried up crusty compound. Get these cleaned off so we can get these transistors installed, but it's fighting me every step of the way. This one's good now. Yeah, I'll just keep plugging away here and turn the camera off and stop complaining. I think the demise of this amplifier was the heatsink compound just wasn't doing its job. Okay, I'm getting close to putting the transistors in, getting things prepped. I got these surfaces clean. They are nice now. I'm going to reuse the old mica washers because they will fit on the new transistors. And I'll just have to clean them up because they have all that crusty white stuff on them. So I'm going to do that, and then we'll put the transistors in. I did some modifications here. There's some wires that were on the back side of the board. I didn't like that. They were kind of in the way, and so I reduced them and replaced them. So there's one wire. These, you got to pay attention to how the base terminal of each of these transistors is wired up, because they're wired in parallel on some of these, and some of them they're not. So I took this wire and I ran it. I'm going to run it under the transistors and keep that off from hanging out the board. Shortened it up. I took this one and did the same thing. I'm going to run it under the transistor, and this wire runs from here to approximately, where is it? Up here. And then there's if you watch this transistor here, you see the base connection for this transistor winds all the way around here, goes up to this base transistor, winds up all the way around here, and then goes to the circuit board here. But this one, it goes from here to the wire, jumps across to here. This one here had a wire that was, where is the wire? There was a wire here that ran from here all the way around to here to connect to this wire, to this base, and this came from here. So like, these aren't very good because they're very thin and they can break, and that would lose your, you'd lose your base connection right here on these because they have a trace running on it. I don't know why they did this, because this is very flimsy and it gets brittle when it gets older. See, here's another trace that runs, this base connection runs from here all the way around to here, and then goes up, and then it goes, tees off and goes down here to this base connection. So I removed all those wires and fixed it all up so that it's a lot cleaner. Another thing they had is they had ground wires running from, this is the main filter capacitors, this is our main ground. These are our two main grounds, one for each channel, and they had them running up here on copper traces to these grounds, and this is, I think, is our star ground connection for the amplifier. They pick off on the other side, there's a lot of wires connected to these two posts, and they had 18 gauge wire running from here up to here just to provide lower resistance. And I removed all these wires and I soldered copper braid right onto the track just to thicken it up and provide a beefy low resistance path for the ground. PNPs in the middle, NPNs on the outside. I'm using the old mica washers, and I'm putting in these ISC 2SC 3858s and 2SA 1494s. These are pretty stout. These are 200 volt transistors, higher current than the originals. These will work really well. So I'm going to put these in. I'm using this stuff. I bought this tube on DigiKey, and I'm not pleased with it at all. I paid $200 for this tube of heatsink compound, if you can believe it. Now it's S putty 5, thermal conductive putty. I don't know, it's maybe it's an old tube or something. I have a hell of a time getting it out of the tube. It's so stiff, and it's just like it is a putty, and it comes out as a blue. It's not tacky or anything. It's like a putty. And what I did is I put down the putty, and then I put down the mica washer, and I just massaged it with my finger just so that it kind of spreads out. And then I put another dab of putty on top of the washer, and then I just screw down the transistor, and it spreads out as it goes. This is supposed to have the highest thermal conductivity of any of these heatsink compounds. That's why I bought it. I thought it was good, but you know, DigiKey. So just putting in the last transistor now. I'm cutting the leads as I go. I just make sure that they're cut the right length. And we can do one right now if you want to stick around and watch. Let's see here. Line up the holes from above, and then I just, with a pair of nippers, I just mark where I need to cut the lead. I just nip them like that, and then I just give it a bend and break these tabs off, leads off. And then screw it down. And I haven't tightened any yet. I'm going to go through and torque them all. So this putty will squeeze and form out. Probably once I tighten these down. Just give it a chance to flow. Go through and tighten one at a time. Just don't go crazy on the torque yet. Just give it small increments. Just give it a chance to flow out. I can already see it squeezing out the bottom and the top. So I'll go through, tighten them all down, and then it's solder time to the board. Probably push these down a bit. And then we'll get this thing going. So yeah, I think these transistors will work good. These are, can't remember what I paid for these, but I bought 10 of each. So I have plenty more. So I'll get this buttoned up, and then gotta install the caps. That's next. And then we're pretty much done. Alright, we're back together, and I believe I'm ready to do a controlled power up. I don't think I missed anything. I did find that when I was connecting the input, one of the cables broke off the post here, and I had to resolder that. So I caught that before it caused a problem. Everything's put back, all the grounds are in place, power wires. So we're going to do this, turn it on. Get my Variac. I'm going to control it, turn it on. Got 0 volts now. Let's go up slowly. I'm going to watch the ammeter. If anything goes weird, I'm shutting it down. Here we go. Looks like we have a working amplifier. Okay, great. Let's do it on full power. Shut all this off. Let's do it on full power. Here we go. Can you see these lights? There's a red light on top and a yellow on the bottom. That's our standby power. So let's do this. $12, kicks on, jumps up to 80, 90, 100. Oh my goodness. We got bad biasing here. So let's let me get the instructions and we'll do the bias setup. I think I have to, well, I can connect from above here. These emitter resistors in the middle you can't reach. So I'm going to connect from the bottom. And there's actually, well, there's 8 transistors, there's 8 emitter resistors. So they want us to monitor current on each leg of the transistor. So let's do that. Alright, I got the spec here. It's DC balance is 0 volts, VR 401, 402 for 0 volts. And then idling current, test point, blah, 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 50 millivolts. That's pretty high. At 75 milliamps. What kind of resistors we got here? 0.33 ohms, 50 millivolts. That's quite a bit of current. 75 milliamps. I don't know what where voltages are, plus and minus 60 volts or something like that. So let's turn this thing on and let's turn down the bias so that we don't get crazy current. For our light to turn red. I'm going to see if this has an effect. It does. Turn this channel down. Let's turn this channel down. That one was turned right up. How about that? Okay, let's turn these right down. 22 watts. It's just sipping current now. So let's do our DC balance. Let's get my voltmeter ready. Let's see if we can get this in frame here. We got 36 millivolts. It's pretty good. So that's this channel. There we go. A little too much. Try and get it close to 0. Pretty good. Let's do the other side. How do I get this side? $79. All right. Let me get my test probe set up for doing DC bias and then I'll bring it back. Now the procedure is to set the DC bias on this emitter resistor, I believe, and then you confirm that those two in the back are following suit with these two. If you have 50 milliamps on here and crazy high current on the back one or no current at all, then you have a problem. You have to fix it. But if you have 50 milliamps on this one, roughly 50 on that one, plus or minus a few, you're good, because these two sets of transistors have to work in unison, right? And they can only do that if they have the same current. So we do in this one right now, and I got 1.1 because I turned it right down to nothing. Let's turn this one back up to 50. That seems a lot of current. It might go a little light on that. So let's go here and start adjusting. $50 millivolts. Oh, hang on a second. I'm doing it across both resistors. I need to confirm. Yeah, across both resistors. So that's 25 millivolts per resistor, which is okay, I guess. Seems a little bit more normal. So let's keep going up. See, our wattage is going up as we increase current. I'll set it to 45 and then I'll let it warm up, because this will warm up. Okay, we'll leave that right there for now. So we went up 17 watts, 15 watts. So we're going to start dissipating 15 watts on this side. Okay, I'm going to remove my probes. I'll be right back. Alright, connected to the channel now. Going up. See, that's all the way down. Okay, 45. And we're idling at about 52 watts, 51. I'm going to let this sit and warm up. Okay, this thing's been on for about half an hour now. I've got adjusted both sides right around the 44 mark. I'm going to leave it there. A little on the low side, I know. It's drawing 47 watts, which is, I've seen power amplifiers usually around 60 watts. And yeah, you can feel this getting warm. So typically it's going to be 40, 44, somewhere around there. I think I don't have any bottom cover or top cover on, and I'm sitting right on a carpet. There's no air circulation from below. But what I'm going to do is I'm going to put the bottom on, just temporary, just to rise it up, and then we'll start testing this bad boy. Alright, we're ready to do power test. I got my load connected. I'm going to have a fan blowing on this time because I'm going to have a couple hundred watts coming out of this thing. And if we're going to do 10 minutes, I'm just going to get it fan cooled this time. So, we have everything ready to go, except maybe it's not plugged in. And let's do this. Okay, turning on. Caps are charged up. And we are ready. So let's see what kind of output we have here. One thing I like about this is there's no relays, there's no switches, there's no nothing. It's a straight connection from the input to the amplifier. No switches, no pots, anything to get in the way, cause problems. Same with the output. Straight from the emitter resistor, there's a wire that goes out the back. And yeah, that's what you want, I think. Okay, let's turn this up. Looks like we got one channel, but not two. Okay. Why don't we have two channels? Okay, we're sitting at 125 watts. What is this thing doing? Let's turn it up some more, see if we can get clipping. Yeah, there's our clipping. But we only got one channel. So let me shut this down and then we'll figure out what's going on with that right channel. Okay, that wasn't hard. This wire broke here. This is the input wire. You can see it. It's not a very good. You got this mess of ground wires here. Look at this, the way they did this. But anyways, I just got to reconnect this and then we're back in business. So just give me a second here and we'll get that stripped and soldered. Okay, take two. Here we go. Power on. Can you see the watt meter? I hope so. It's going to go into auto protect. Here we go. And we got both channels on full. That's quite a wake-up shock for it. Okay, let's do the top one. Let's take this up to clipping. Right there, back it off. Probably right there. I'm going to say we've got 28.34 volts RMS on that one channel. Let's start our timer. So we're starting off cold here. Temperature right now 30 degrees. Okay. We'll be back in a few minutes. Okay, we're at the 10-minute mark here, and things are cooking along real nice. I think our maximum temperature is hitting 60 degrees. 60 degrees in the heatsink, which is fairly good. So we're doing okay on the heat sinks and the heat. We're not there yet with anything that's critical. I'm kind of concerned about the power output though, because we're down on power. I'm reading 28.18 volts right now. Let's see if we can max this out to clipping again. I don't know if I have it low and high enough. See, it is clipping there, definitely. Let's take it down a bit. Right to that point. 28.52. And that's only like, let me calculate it. 28.52 divided by 8. I'm getting 101 watts. I was expecting a little bit more than that. But it is what it is, I guess. It's been going 12 minutes now, full power. No problems. Okay, so let's turn this down. And let's look at a square wave. Let's turn this and do this at reduced power. Alright, going up. Wow, look at that. That's 1,000 hertz tone. I didn't get much better than that. Okay, that's 1,000 hertz. Let's go up in frequency. $10 kilohertz. Looking pretty good at 10 kilohertz. $20 kilohertz. Starting to see the effect, and we lose it right around, probably right around here. 40 kilohertz. This thing has a power bandwidth of, or frequency response of something like 0.1 hertz to 170 kilohertz. So let's test that out. Let's go down and let's go up in frequency. Let's get out of here. Let's go up in frequency to 50. $85 kilohertz. $130 kilohertz. Still looking good. Here's 170 kilohertz. What's going on with 170 kilohertz. It's doing pretty good. Let's do the low end. Here's 1 hertz. Half a hertz. That's 0.5 hertz right there. Go down. 0.2 hertz. Pretty amazing. This amplifier is incredible. Okay, I think we're done playing around here. I'm going to let this thing cool off, and then I'll look at the power consumption when it goes up and down. Okay, let's shut that off. Okay, let it cool, and I think that's a wrap. Alright, so the best part is I gave the lid a scrub, and you can see how nice and clean it came out. There is, where is it? It's down here. You can barely see it. There's a scratch. See that? It's like a scuff. And then there's a little scratch. That's about it. But this lid came out really nice. I scrubbed it down and it was pretty filthy. It had some kind of overspray on it. I think it was either hairspray or furniture polish or something, but it was stuck there and nothing would take it off. And then I found residue of a sticker in this one corner, so maybe this was a Goodwill find and somebody just listed it on eBay. I don't know. But anyways, I'm going to offer this one up for sale for my subscribers. Yes, you must be a subscriber, and if you're interested in buying it, make me an offer, get in contact with me. You find my email in the my channel page in the about. It's really difficult to find. There's a description of my channel, and then it has the word more. You click on the word more and it opens it up, and then you'll see my email address. And if you're interested in making an offer, shoot me an email and we'll have to work it out. But I think I'm going to offer this one up because I don't have any use for it. Now it does have a scratch along the front, which I cleaned up. I want to make sure that you guys see this before you know. There is a scratch right across the full face of it. I cleaned it and it kind of almost disappeared, but it's still there. I think maybe a pencil eraser. Pencil eraser might do it. No. I don't want to use any cleaners because this is aluminum and you can't really put any cleaners on aluminum. But it does have some blemishes, but you saw how it performs and you saw all the work that went into it. So if you're interested, let me know. So the big story for this one was dead transistors. I think what happened is somebody maybe got inside and they're dicking around with the bias setting and they cranked it right up on that one channel. And it cooked that channel. It got so hot that it just fried everything. Thankfully it was just these transistors and nothing else really. So I replaced all 8 transistors. That was the big story for this one. I replaced caps. Caps are actually fairly good quality because well, there's two kind of caps. The red ones and the blue ones. The blue ones are Mashishita and they are garbage. They lost value. They're leaking down the leg, like typical Mashishita caps. So they got replaced. And then there's these kind of dark red, burgundy, Elnas. These are for audio. It says right on them for audio. If you can see that, it says for audio. And these are actually really good caps. I'm surprised. They have a really low ESR, and they have great big thick legs, like they're made to handle current. And yeah, if you look at these legs, they're like really thick and they're difficult to bend. They hold their value and they hold their ESR. Really good ESR on these, but I replaced them regardless. They're audio grade, but they had them in the power supply section, which didn't make sense to me. Well, maybe it does because they're audio low ESR. So I'm going to put this all together, finish cleaning it up, and still have to put those covers over the transistors. I still have to clean them and put them back on. So I'm going to do all that and then finish this up. Alright, that's it for this one. I'm going to close this one up. I'm going to test drive this one for a while. Stay tuned. Got lots more stuff coming. And thanks for watching.